Hey guys, and welcome to week 9 of your algebra class. In this class, we're going to finish up with everything you guys need for your nursing class, or your nursing math, I should say. And these are some more things that you guys will see throughout your program at ATA. What we're going to take a look at today, and I'm going to kind of slowly introduce you into it. We're kind of combining what we learned the last couple classes. We talked about using our dosage formula, our D divided by H times Q. With that, what we did, and the reason why we used this formula, when we were given a dosage, so something in milligrams, grams, micrograms, it could be even units, whatever it might be, these are all, or even you might at some point see milliequivalents, rare, but every once in a while, these are all a dosage, so meaning how much medication a patient needs. So common, we saw milligrams, so and this is just a, kind of a refresher from what we talked about in the last couple weeks. So if, a doctor ordered 50 milligrams, that's how much medication a patient needs. Well, it all depends on how that medication comes in order for us to determine what we give that patient. If this medication comes in, let's say, 10 milligram tablets, then that means a dosage we have on hand is 10 milligrams per every one tablet. Let's say, and so what we did was 50 divided by 10 times 1 to determine that they need 5 tablets. In the event that they ordered 50 milligrams again, just separating this here, let's say, what if they came in, let's say it came in, let's say 25 milligrams per 2 milliliters, meaning for every 25, or I'm sorry, for every 2 milliliters of liquid in that medication, you get 25 milligrams. So therefore, that's our H and our Q in our formula here, and we did 25 divided by 50 times 2 to determine that they need 4 milliliters. So, we use this dosage formula to determine what we needed to give our patient. We know how much medicine they need. This is what the doctor wants us to give them, no matter what. But it all is dependent on how that medicine comes, and that's why we use that D over H times Q formula to then determine what we give them. And so that's what we've been looking at and why we've been using this formula over the last couple weeks. So we're going to do the exact same thing today, but in turn, we're going to take a look more closely at really at this, situation where the medication comes in liquid form. In this case, we're specifically looking at the fact that it comes in an IV, and we need to determine not just how many milliliters, but how many milliliters we're going to give per hour. So we're kind of combining dosage calculations and our IV calculations that we looked at last week. So here's what's happening. So let's say, very, very similar to what we just took a look at, let's say we have a doctor's order. Doctor orders, say, 50 milligrams, once again, but this time the doctor says that that's how much medication they need per hour. Again, the fact that it's in milligrams means that we know how much medication they need, but it depends on how it's diluted. It's a liquid medication, so it's all dependent on how it's diluted. So that's where what we have is really important. So how it's packaged. So if this says that this medication comes 10 milligrams per every 2 milliliters, and the question says, well, what do we give in, how do we set the infusion pump in milliliters per hour? So right now, what's great about this question is it's already been ordered per hour. We already know that this person needs, 50 milligrams, and that's how much medication they need per hour. So when this is put into the dosage formula, my answer is going to be in milliliters because that's what my quantity is, but it's also per hour. It's already set, it's already set per hour. So if we were to plug this in, and let's use green here, our dosage formula. So again, this should look very, very familiar. And you guys are going to think, well, okay, this is exactly what we did, a couple weeks ago. And that's true, but I'm going to, like I said, kind of slowly build into this to show you how sometimes these are asked. So our H, again, is 10 milligrams per our quantity of 2 milliliters. So again, because it was already milligrams per hour, our answer, what happens is, milligrams and milligrams cancels out, and it's going to leave me with milliliters per hour. So that's exactly what I'm looking for. So that's all we're going to have to do here. No converting or anything. We're going to go ahead and just divide this out. 50 divided by 10 is 5, times 2 is 10. So this person needs 10 milliliters per hour is how I would set that infusion pump. So a little bit different than when we were calculating milliliters per hour last week, where it was just, okay, here's the total amount of milliliters they need over this course of so many hours. So what are they getting in milliliters per hour? You know, that was a little bit more straightforward. In this case, we're incorporating the dosage. You know, how much medication based on how it's packaged. Okay, now what would that be in terms of milliliters per hour? So it's very, very similar to what we've seen already. If I said, you know, I have an ordered dose, let's say, of just, you know, like we've seen before, if it's something other than, you know, how the medication comes. Let's say doctor orders, how about 100 milligrams per hour, once again. And let's say we look at that medication, and this says that we have a medication that comes in 0.2 grams per every milliliter, for instance. Okay, so how would I set that in milliliters per hour? That's what all these questions are going to ask, is milliliters per hour. Well, once again, we just set up it's already per hour, so I don't need to worry anything about that. I want to go ahead and set up my D over H times Q formula. But just as we've seen before, you know, we need to make sure D and H are matching units, and because they're not, we're going to have to convert. And once again, out of habit, I typically just get everything into milligrams, so I'm going to go ahead and convert that grams to milligrams on the bottom there. So 0.2 grams, 3 places to the right, or times 1,000 with our metric methods there makes this 200. So 100 divided by 200 is 0.5, times 1 is still 0.5, so this person just needs 0.5 milliliters per hour. So see what we're doing here? So really a way to think about this, I'm going to show you again a little bit more with it, is think about, okay, here's what we have right now, milligrams per hour, and I want to know what that is in milliliters per hour. So the great thing about this is it's already an hour, so we're already set there, so we don't need to do anything. But to get from here to here, that's what we've been doing so far, you know, in the last couple weeks using our dosage formula. So in order to get from a dosage to milliliters, meaning how that's going to be given, we have to incorporate that into using, we have to see how it's packaged. So again, using that H and that Q to convert that from milligrams to milliliters. It has to be packaged a certain way. So that's essentially what we're looking at here. But what happens when maybe it's not ordered per hour? Let me show you what I mean. Let's say instead of, you know, being ordered, how about, you know, so many milligrams per hour? What if it's so many milligrams per minute? Per minute. And then once again, we're told how, you know, the medication comes. Let's say we have a medication that is 100 milligrams per 25 milliliter or something like that. Okay, so what that means is, okay, and again, we're being asked the same question, milliliters per hour. Once again, think about what I just showed you guys. Here's what I have right now. I have a medication that's been ordered as so many milligrams per minute. I need to get to milliliters per hour. So think about the two things that need to be done here. And the two things that need to be completed, I'll tell you guys, it doesn't matter which order you choose to do this in. You can do, you know, and I'll draw this in red. You can do this first, or you can do this first, and it doesn't matter. And I'll show you guys what I typically do, and you guys may kind of develop the same habit. But just as I mentioned before, in order to get anything from a dosage, whether it's grams, milligrams, micrograms, units, you name it, in order to get from a dosage to liquid, we have to incorporate how it's packaged. So that's where D over H times Q comes in. Now to get from minutes to hours, that's where we have to kind of know our relationship between those two units. We know that there are 60 minutes in an hour. So in thinking about just what we have up here, if a patient is getting 5 milligrams per minute, meaning that's what they're getting every single minute. That means they'll get 5 more in 2 minutes. They'll get 5 more in the third minute, 5 more in the fourth minute. And you see where I'm going with this. They're going to end up doing that 60 times in an entire hour. So therefore, in these situations, in order to convert from minutes to hours, we're going to have to end up multiplying by 60. Because that's what's going to happen here. If they're getting 5 milligrams every minute, they're going to get 60 more of that in an entire hour. So we can just multiply by 60 to see what that is per hour. And then it just kind of looks exactly like the problem we looked at a second ago. So that's what I do, is I start with that. So let me get this out of the way down here. And let's stick our calculation down there. So that's what I always do first. I say, okay, well, if they're getting 5 milligrams every minute, they're going to get 60 of that in an hour. 5 times 60, I know, is 300. So that means what's been ordered, 5 milligrams per minute, is the same thing as 300 milligrams per hour, since 5 times 60 is 300. So now we're using this. Now we're using this because, again, it's the same thing as this. We just, again, need to see what it is in terms of hours, since that's what's being asked of us. And that's kind of the most important thing on these questions, is we're looking to see what we need, what's being asked, and we need it to be in hours, and we've done that. So we've checked that off. We've got it from minutes to hours. Now, once again, to get it from milligrams into milliliters, the other part of what we're looking for, we need to use our dosage formula. So completing that, I'm going to go ahead and divide by 100 and multiply by our quantity of 25. And then since milligrams and milligrams are the same, I don't have to do any converting. So I'm going to go ahead and take 300 divided by 100, which is 3, times my quantity of 25, means that this person needs 75 milliliters per hour. And we're good. That's what we were asked, and that's my answer. It's just milliliters per hour. So it's always just a matter of taking what we have, what's been ordered, and let's see, how we get to what's being asked of us. Okay, so another situation. Let's say this. Let's say doctor has ordered, let's say 2 micrograms per minute. We have a medication that comes, how about, I don't know, let's say 100 milligrams per 250 milliliters. I just made this up, so I don't know how this is going to work correctly or not. But once again, how would we set the infusion pump in milliliters per hour? So again, thinking about what's been ordered, micrograms per minute, and don't be thrown off by the micrograms. I'll show you guys what we're doing with that. And we need it to be milliliters per hour. Once again, to get from minutes to hours, that's where we're going to have to times 60. To get from micrograms to milliliters, once again, we just need to incorporate our dosage formula. So, and like I said, don't be thrown off by micrograms. That is simply just another unit we'll have to convert to get D and H to match. So, let's go ahead and get that out of the way, and I'll show you guys what I mean by that. So once again, I like to go ahead and start with, okay, if they're getting 2 micrograms every minute, they're going to get 60 of those in an entire hour. So let's go ahead and multiply that. When I do, 60 times 2 is 120. So that means they are getting 120 micrograms every single hour. So we've already got that checked off. We've got it in hours. Now I just need to get it into milliliters. Once again, that is simply going to be just a matter of putting it into our dosage formula. So taking what we have, 100 milligrams per 250 milliliters. Now, as we've learned before, I cannot go ahead and divide this out because I need my dosages to match there. So as usual, I go ahead and just get them into milligrams. So my top unit there in red, the 120 micrograms, micro to milli is 3 places to the left, or dividing by 1,000, which would make this 0.12 in milligrams. So I know that's kind of this is going to kind of be strange, but 0.12 divided by 100 is 0.0012, but then multiplying that by 250 means that we get an answer of 0.3. So strange answer. Like I said, I didn't think it would work out perfectly, but either way, that's what we would get in terms of milliliters per hour. It's just a matter of, again, putting it in hours and then getting it into that dosage formula. So looking at another one of those. Let's say we've ordered, how about 4 micrograms per minute. Once again, just looking at kind of the same idea here. And we have a medication that is 25 milligrams per 500 milliliters. So this one might end up with a bigger number here. Okay, so once again, we're being asked, how do I get it to milliliters per hour? So thinking of what we have up there, what's been ordered, 4 micrograms per minute. Well, 4 micrograms in a minute means 60 times that in an hour. So 4 times 60 is going to give me 240 micrograms every hour. So now we're looking at it. We've got it in terms of hours. So we've got that checked off. Now it's a matter of getting it into milliliters, and that's going to be getting it into our dosage formula. So this is packaged as 25 milligrams per 500 milliliters. Just like the last problem, I cannot go ahead and divide this out. I need these two to be matching units, and they are currently not. So as usual, I just get everything into milligrams, but again, you all don't have to do that. You could get everything into micrograms if you wanted to. Totally up to you. But I'm going to go ahead and convert that top unit into milligrams to show that 240 micrograms is the same thing as 0.24 milligrams per hour. So we're just looking at it the same way, that it's the same thing. So now I can go ahead and divide, since both D and H are in milligrams. 0.24 divided by 25 is 0.0096. Multiplying that by 500 gives me 4.8. So this person would need 4.8 milliliters per hour. So hopefully that's not too bad. Again, it's just a couple steps involved. We need to see what that would be per hour, so we just kind of think about that. You know, right now it's per minute, so how do I get that into hours? Well, there's 60 minutes in an hour, so that's going to have to be what happens first. And then we get it into, our dosage formula. So one more thing that might be added in these types of questions, and that would be our patient's weight. Every once in a while you might see questions ordered this way. Let's say what's been ordered is not just 4 micrograms, but this time it says 4 micrograms per kilogram per minute. And these are pretty common on those ATI type questions that you guys will see in your nursing classes. So 4 micrograms per kilogram per minute, which means that they need this amount of drug per every 1 kilogram that they weigh each and every minute, is kind of how we can break that down. So once again, we'll be given, okay, here's how the medicine comes. So we have a medication that is, let's say, 100 milligrams per, let's say, 500 milliliters. And the patient weighs, so their weight is, say, 45 kilograms. And I want to know, sorry, that's a K. I want to know what that would be in milliliters per hour. So a couple more steps in this case, and thinking about what we're working with here. So once again, we've ordered micrograms per kilogram per minute. And we need it to be in milliliters per hour. So the same steps are actually going to be involved in these. I'm going to need to take a look at, the multiplication of 60 to get it from minutes to hours. We're still going to use our dosage formula to get it from, a dosage to milliliters. The only extra step we're going to have here is this one right here, that we need to incorporate the weight. Anywhere you see dosage per kilogram simply means that we're going to have to incorporate that kilogram weight. So we're going to end up multiplying by that weight. So I'll just put multiplying of kilograms to get to our answer as well. So let me show you how, I approach this, and then it will end up just looking like the problem we just finished up with. That, since we've got 4 up here at the top, we've got what's been ordered is 4 micrograms per every kilogram, which means they need 4 micrograms for every one of these 45 kilograms. 4 micrograms per every one. So 4, if a person was only 1 kilogram, they would only need 4 micrograms of dosage. If they weighed 2 kilograms, they would need twice that. So we would take 2 times 4. If they weighed 15 kilograms, they would need 15 times that dosage. In our case, since it's 45 kilograms, they would need 45 times the dosage. So what I always do is I take that as my first step. I multiply by that weight. In our example, it's 45 kilograms, because then that helps me to get that part out of the way. That, again, that it's so many micrograms per kilogram. 4 times 45 is 180. So now we've already eliminated this part, meaning that this is the same thing based on our patient's weight. They need 180 micrograms every minute. If it was a 60 kilogram person, we would have multiplied it by 60 to show that they need a little bit more per minute. If it was only a 20 kilogram patient, we would take 4 times 20 to show that they need a little bit less per minute. So this is just, again, incorporating that patient's weight first to kind of get that out of the way. And now it looks very similar to the problem we just looked at a second ago. So now that we have it in micrograms per minute, it is still per minute. So I like to go ahead and convert that into hours to get that step out of the way. I'm just kind of following the same steps we did on the last question. So I'm going to go ahead and multiply that by 60 to show what that would be per hour. 180 times 60 means that this person needs 10,800 micrograms. It is still in micrograms every hour. So we've taken care of that. We've already got the per kilogram out of the way. Now we've moved it from minutes into hours, so we've got that checked off. And now I just need to plug it into my dosage formula. So in doing so, again, I like to get everything into milligrams first. So because it is, how it comes is in milligrams, so I'm going to go ahead and do that. 10,800 is the same thing as 10.8 milligrams, since I've moved my decimal 3 places to the left, or taking 10,800 divided by 1,000, and then incorporate H and Q there, how it comes. So 100 milligrams per every 500 milliliters. So taking 10.8 divided by 100, and then taking that and multiplying it by 500 gives me an answer of 54. So that person needs 54, oops, horrible handwriting here, 54 milliliters per hour. So I know that seems like a lot of steps, but it's actually just one extra step from what we did on the last equation. So looking at another one, let's say we have an ordered dose of, say, 3.5 micrograms per kilogram per minute. And we have a medication that comes packaged as, let's say, 200 milligrams per every, let's say, per, 500 milliliters again. Okay. So, I need to incorporate weight as well. And let's say we have a patient who weighs, how about 50, let's say 55 kilograms. So I want to know, what would that be in milliliters per hour then? So once again, think about what's been ordered, what we're dealing with up there. Anytime I see per kilogram, I always think, okay, I need to multiply the weight. So I'm going to go ahead and do that first. I'm going to multiply by my patient's weight of 55 kilograms. In doing so, 3.5 times 55 gives me 192.5. Let me make sure I did that right. 3.5 times 55. Yes. So that means this person, based on their weight, needs 192.5 micrograms every minute. Once again, what we've done is we've eliminated this part by multiplying it by that kilogram weight, and now we're down to micrograms per minute. It is per minute, and my question is asking me for hours. So I'm going to go ahead and do that. I'm going to multiply by 60 to get it out of minutes and into hours. So just leaving that in my calculator, 192.5 now times 60 gives me 11,550. So 11,550 is now no longer minutes, it's now what that person needs in micrograms per hour now. So we've got that taken care of. It is in hours. I need to get it into milliliters now, milliliters per hour. So that's going to be using our dosage formula. So I'm going to plug that in over on the side. I always like to use milligrams since that's how our medication is going to come. So converting that 11,550 micrograms into milligrams, that would be 11.55 milligrams. And then my H up there at the top is 200 milligrams per every 500 milliliters. So dividing that out, 11.55 divided by 200 gives me a very small decimal. Multiplying that by 500 tells me that this person, and I'm just going to round it off to the tenths places, that's pretty common. I got 28.875, so we will just call that 28.9 milliliters per hour. It's pretty common on the ATIs. Typically when you have decimals like that, especially with milliliters, it oftentimes will ask you to just round it to the nearest tenths place. So that's what we're working with on those. So you'll see questions that may just start off as, like we did at the beginning, where it just starts off as, okay, well, patient needs so many milligrams per hour. Okay, so that's just plugging it into the dosage formula. When you see that per minute and it's asking for hour, we need to think about how we get from minutes to hours, and that's where 60 comes in. And then when you incorporate the weight, you simply have to also multiply by that weight. So like I said before, always take a look at, what you have right now. So meaning what's been ordered right now. If it's just milligrams per hour and we need it to be in milliliters per hour, well, you're good on this step. You don't have to do anything there. But here, always to get from any dosage unit to liquid, so from any grams to liters, in our case, milligrams to milliliters, we're going to have to use that dosage formula. In the questions, in the event where you have, like I said, milligrams per minute, and you need it to be in milliliters per hour, now 2 steps are going to be done. Still need that dosage formula, but you're also going to have to incorporate multiplying by 60 in order to get it from minutes to hours. In the event where you were ordered, instead of, I didn't mean to use the highlighter there, I meant the pen. In the event where it was ordered as micrograms per minute, it was still the same idea. You're still going to, have to, that's supposed to be hours. Still going to have to use that times 60 down here to get it from minutes to hours. And same idea here. You'll still need to use that dosage formula, but the only thing you'll need to look out for is pay attention to the units. Since this is micrograms, your H might be in milligrams, so you just might have to do some converting, as we've done many times before. So just be on the lookout for that. And the last thing we just looked at was when we then incorporate weight, meaning that if it's ordered, per kilogram per minute, there's just one little additional step there. So what we did was we multiplied by that kilogram weight, whatever that might be first. We then took that answer and multiplied it by 60 because again, I don't know what that is, 60 to get it from minutes into hours. And then we also incorporated the dosage formula to get it from, micrograms into milliliters. So there was just that one little extra step where we had to incorporate that patient's weight. So that's the big thing to look out for on these, is think about what's been ordered and then how we get to what we need or what the question is asking us. All right, guys, I hope that helps. I know that's kind of a short and sweet lecture, but I hope that it reminds you of what we've done so far with our dosage calculations and using that D over H times Q formula, but now with just a couple extra steps to get it into, milliliters per hour now. If you guys have any questions at all, please don't hesitate to ask. I do have a few review videos on this that may help you with it as well. But like I said, feel free to reach out to me anytime. Thanks, guys.